So throughout this month, we'll be covering web applications specifically. It's Web Application Month. We've covered some web application topics like in the past already, like the upload vulnerability room we did pretty recently. That's an example of a web application, a very basic web application. But we're going to be more focused specifically on web apps this month. So today we'll be covering, what constitutes a web app, and we'll also be learning how to use OWASP ZAP, which is a very robust framework for web application testing. So what are web applications? Web app is just an application program that is stored on a remote server and delivered over the internet through a web browser. It's different from a regular website just because like a regular website is static and they're more there to deliver information like a blog, I guess, like an about me page. That's just a website. That's not a web application. Sites that you interact with are web applications. So like Reddit, Twitter, or Facebook, Wikipedia, those are all pretty relevant examples of web applications. What builds the web app? So you don't just have the server language as the web app. Of course, your web application runs on servers. And usually if you have any kind of user input that's stored, if you have any user accounts or anything, then you also have a database on that web app. And so the server itself can be real hardware or virtual, and the database is usually SQL, although there are a couple of non-SQL databases that are starting to be used more commonly. And then you have the application itself, which is most commonly PHP, like is most commonly made in PHP. But again, more alternatives are being used like Python and Ruby and Rails. There's a lot of web app languages. So when it comes to the languages used for the web, they fall into two main categories. You've got the client-side languages and you've got the server-side languages. And the client-side languages are what you actually see the direct result of, and is standard just for any website. So that's your HTML, and that's your CSS, and that's like your JavaScript. But the server side is what you shouldn't see. It's what's done on the server end. So when you make an account, the server side language processes all that information, and it builds the web application itself. So whatever the application is what the language will run. And various languages are more secure than others. PHP is not very secure, even though it builds up the majority of dynamic web applications, just because it's like one of the first languages to support that kind of thing. The server's job is to receive connections from the clients and send back valid client-side code. And so the reason why this is necessary is because many times that code needs to be dynamically generated. So like as an example, if you go to your subscription page on YouTube, your subscription page is going to be pretty different from my subscription page. So when we click on that subscription page, it dynamically generates all of that code that's going to be shown to us on that web browser, using like our account credentials and all sorts of data they have stored in their database about like our liked videos and recent watch history and that kind of stuff. And the way this is done is, because their code is being run on the actual server that figures out who you are, and then it figures out what it should be showing you. And so this can be done in many languages. And so in the number one fault of web applications, and like pretty much where all of these web application vulnerabilities pretty much comes from, is just unexpected input. So user input is going to be utilized in some way within a dynamic web application. If you're leaving a comment, or if you're making an account, or if you're uploading a YouTube video or uploading a profile picture, That's all user input. If special care is not taken with this user input, hackers could use, could put in some malicious input, like we did in our upload room. That was an example of a web application, and instead of uploading something like a profile picture, we uploaded a PHP shell. And so we've already kind of y'all have already been introduced to that kind of unexpected input already. But we're going to be going into more detail about the other kinds as well. So some of the most common, we got cross-site scripting, or which I think is better referred to as just like HTML injection. But the standard is just referred to as cross-site scripting because originally it utilized like cross-site cookies and stuff, but it's just general HTML injection at this point. But cross-site scripting, if special are taken, then users can input code which will then be executed by clients viewing that page. So in the associated image on this slide, we got a Twitter user here that made a neat little tweet in 2014 that's just JavaScript code, and it retweeted the tweet when that page was loaded. So in 2014, when this was done, the only thing a user would actually see would just be the heart emoji of that tweet. Everything else, all that other code and that script tag would be inside the HTML page. So like if you opened up your inspect element tool, you'd see it there, and it already retweeted that tweet. So this was like a big funny haha for 2014. And then we got SQL injection, and it's an exploitation of the same problem of unsanitized input, but instead of inputted code being executed on clients viewing the web page, the SQL code or commands gets processed on the server side. So SQL injection can be used to view what's stored in the server's database, and can also be used to alter the database. File inclusion is another example of the same problem of unsanitized input. Like I was saying before, we've done this one with the file upload room. We did a couple weeks back. But if they don't have checks in place to where if you're uploading a profile picture and even if it just checks for the extension, if it doesn't check the actual content of the image, you can put code in the bottom of the image that can then be executed, depending on, of course, depending on how the web application itself processes that kind of stuff. But we'll be covering all these attacks in more detail in later labs. I'm just kind of like giving like a brief overview of the couple stuff that we'll be tackling in the future. And what we'll be doing today is we'll be learning how to test for a couple of these vulnerabilities with a tool called OWASP ZAP. So OWASP ZAP is a framework. It's just used for testing various web applications. It's very robust, and it's a personal favorite of mine. And we're going to be going over how to set it up and how to use it. So give me a moment to change my shared screens to my virtual machine here, which Microsoft Teams is having trouble recognizing exists. Okay, there we go. All right. So in the meeting notes is the link to the room that we're going to be doing, and this is actually a room that I've made. So if we just make sure that you're connected through your OpenVPN packet and deploy the room, and we're really only going to be using it because there is the room I put in an instance of damn vulnerable web applications. So after everything's kind of configured, we're just going to be testing against that and kind of exploring some of the capabilities of this tool and getting hands-on of the kind of vulnerabilities we discussed earlier. So depending on whether you have Parrot or Kali, OWASP ZAP should be installed anyways, like by default. It requires root access, so just put in your password there. And I'll just give you all. By default, your password is just root. Yeah, it's just TOOR. Yeah. We'll also be needing Firefox to be opened up. All right. Is this done? Yeah, okay, this is done. So as an example, we've got this neat little thing, just an automated scan that ZAP is capable of, and it's pretty straightforward. You just throw in the IP, or like the actual URL and everything, and just straight up just hit attack, and it'll scan for standard things like robots.txt is useful. And so right now it's doing an active scan, and I think I just double clicked by accident and it did that. But it'll give you alerts of what kind of vulnerabilities that there could possibly be. Like here, it's categorized a medium risk of X-frame options header not set. But if we navigate to this website, there's a login portal first to actually get into the damn vulnerable web application. And so while the automated scan is able to do this kind of stuff just by itself, to do more involved tasks besides just like an automated scan, we need to set up a proxy between OWASP ZAP and the web browser that we'll be like kind of navigating with. And so to do that, first thing we got to do is we got to go to our options of OWASP ZAP. And that'll just be under Tools, Options. You can also just hit Control-Alt-O. And you can just search in Proxy. And find Local Proxies. Down here, Local Proxies. And change I'd prefer, there's like really no difference between using localhost and your actual like localhost IP, but I just prefer typing out the IP itself. It just makes me feel more cozy. But the default settings here that it comes up with are good enough. You don't need to change anything here. And then when that's done, just hit OK. And then go back to your options, Control-Alt-O, search up for certificate. We've got dynamic SSL certificates, and this is the thing that we're going to be putting into Firefox itself, because ZAP is unable to handle, is unable to see and do like those manual testings of like a brute force attack and more advanced scanning without this step. So don't skip this kind of stuff. Also, the room itself describes this as well. If I move too fast, just let me know. So we can just save this, ideally not in our root directory. It is running as root, but just try to place it like somewhere on your desktop or somewhere. Someplace that you aren't going to delete it. You could put it in your downloads or wherever. But once you've saved that, now we navigate to our Firefox settings. Same thing, we can just search up for certs. Look at our view certificates. And then we're just going to import from here, import certificates. And we'll just navigate to wherever you saved that, and then we just import the OWASP ZAP certificate. and give it full trust and hit OK. And then after that, we only have one more step until we're just completely set up. Now we set up our proxy. And so we go into manual configuration. We just set everything to our localhost 127.0.0.1, or you could type in localhost, but again, I personally prefer just typing out the IP. And also allowed the proxy for FTP and HTTPS. Most of the time, especially for like the try-hacking rooms that we're going to be doing, they don't have certificates, but a couple of them are, and you know, this just ensures that ZAP is able to process those. So at this point, we are set up. So if we here, let's just refresh this. It should see how it popped up there. And also, if we go to another site, let's refresh Parrot Security. Other website. That'll actually load. Yeah. So then we see Google and all these sites and everything else everything that like the web browser basically touches is now imported into OWASP for us to see. But we don't care about Google or anything else. We're just looking at our IP here for the damn vulnerable web application. So when faced with a login portal, what do we do if we don't know the password? In this case, we could just brute force it. So how do we brute force it using OWASP? Well, you're in good news, or you're in luck, because I'll tell you. And it's not too difficult either. So first thing, find the, try to just log in with some random stuff. Username test, password test. Login failed, okay. But we should be able to see that request that we did. Here we go. Go into the request. We can see username. It's open. And so usually if you didn't have OWASP ZAP, there's this other framework tool that's called Burp Suite, and it's like a paid version, and everyone else, or like kind of like the large chunk of the InfoSec community uses Burp Suite, but it's paid. And like as an example for this kind of brute force, it will actually like slow it down. It'll like throttle the brute force, so that way it just, you're incentivized into paying for it basically. So if we go into fuzz, we find our login.php, attack with fuzz. We should see, where's our request here? There it is, okay. So then we see our specific username test and password test. So after we hit that request, it just stored it in here. So let's try right click that request, attack, fuzz, and find in the location of the request itself where that information is. And so we can just highlight it, that both of these things. Actually, I'm gonna change this because I know that the password test. For a little easier purposes. We can just highlight this for the password test and select from fuzz locations our word list, and we can add our word list. And usually in Parrot and pretty much Kali Linux as well, just select file and navigate to your /user/share, and you'll have where all of the kind of like pen testing applications, they kind of just dump their stuff. And so I don't like this file browser. Can I just type in Bearbuster? That is awesome. Okay, I can. So we're navigate over to dirbuster and word list, and we're just going to use directory list lowercase 2.3. So then we can even preview the payload here, and so it's going to try all these passwords where we highlighted password test. Hit OK. And then we can start our fuzzer. I think for testing purposes, I'm going to choose a smaller word list because this is taking too long. I'll just make one. Yeah, because this is only 1% length. Yeah. Attack, fuzz, highlight what we're going to be changing, add our file, our wordless file. I saved that to the desktop, right? Yes. Home, user, desktop, unsaved, open, add, OK, start. And so then that'll brute force through those passwords, and we can log into the rest of this. Oh, and so once so the login is just admin as the username, and then password as the password itself. And set once you're logged in, go to the DVWA security page and make sure you set it to low, because otherwise the rest of the examples here won't work. So again, we've got like another one, which is actually probably would have been the better thing to use. Admin test pass. Can find vulnerabilities per username. Oh, okay. So so this one's a little different, but it's the same. It's the same theory. Instead of the stuff being down here, it's in the header text itself, because it passes it through the URL instead of the content of it. Same thing. We can admin, and then we have test pass here. Highlight it. Add a word list, and I really wish it stopped locating it in the root directory. I wish it saved the last location you were in. It'd make things a lot quicker. Dirbuster word list directory, word list add, OK, and then start fuzzer. And so some of them will give a different status, so you will sometimes get false positives, but am I getting the majority of false positives? Man. Oh, it's because the characters are like less than 8 long. Okay, so yeah, that's another example. So if you know that the password requirement is, 8 characters at a minimum, or like includes special characters and stuff, thin out the word list that you use so that way it only includes passwords that will actually meet those password requirements. So this one is just 8 characters long. So all the other ones that will be reflected that are see how they're just kind of short like that? But that is how you would brute force. That's how you use your fuzzer. But there's other things that we can test here. So like SQL injection as an example. Let's apply is something that we looked at during our slideshow. And so later this month we're actually just gonna be having like a whole day on just SQL injection, but as like a brief intro, we'll go over it since it's here. And so this little application just asks for user input to like put names in a database, I guess. And so this one's neat because it'll even show you the view source so you can kind of get like a good understanding of what's going on in this example. So we can look at the command here. This statement, so first where's the statement here? The statement bud's in the way. So this is the full statement. For better readability, I'm gonna put it in a text document. So this is what's going on, and so the ID here is where it gets the input, and it just puts that input like directly in the SQL command itself. So whatever your input is, it will just put in the statement. So if we end up closing this bracket, so that way instead of like ID equals, ASD or whatever, we can have it equal anything basically using this command. And so then it'll say, so instead of where it'll be like it's asking for a user ID for you to input. And so then this checks, it will return the first name and last name from users where the user ID like equals an actual successful user ID. But instead, we're just putting in where user ID equals blank or like literally anything. So if we try that and we just put that in itself with or, and so there's also like SQL injection cheat sheets and stuff. So you don't have to like have a full thorough understanding of how SQL works, or like you don't need to be proficient in like SQL databases or something. And ta-da! It returned all of the stuff in the table there. Also, to kind of also reiterate on the robustness of this tool, you guys have used GoBuster before, right? GoBuster or Dirbuster? I'm pretty sure we've used it in one of our labs before. Yeah. Yeah, so here's another neat thing. Oh, well, before we can brute force directories, we need to pass in that we're logged in here. So I'm gonna go over that. So at the beginning of DVWA, it had that little page, that initial login page, and so we were able to scan that. And currently, that's kind of like unless this has changed, maybe I'm going off of old information, but I'm gonna go over with how it was done. So this is in Firefox. What's Control-Shift-I is inspect element, and so then we can find all of the other internal information, but also where our cookies are located. So let's find our cookies, and let's find our PHP session ID. And so that means that we're authenticated. And so that's another thing we're going to be covering, as well as like bad authentication. A lot of times you log into an application and it will just give you a cookie, and that cookie just means like, okay, if you've got this cookie, that means you're authenticated. And we did a bad job, and that cookie like doesn't expire, and it's not dynamically generated, and you can just guess the cookie because it's also made in base 64 or some other stuff like that. But in a good application, you won't have this. But take note of that PHP session, and then you can just add that into your sessions tabs, and you can set where is this? HTTP sessions, yeah. And then we can add the new session, change our values. I'm trying to change the values. Oh, okay. It just automatically imported it now. Okay, so ZAP got some updates, and you don't even have to manually do that. That's cool. That's cool. Okay, but we're going to set this one as active. And so now we'll be able, well, we were already able to, but I'm just operating off of pretty like old knowledge. So here's another thing that we could do. From the attack menu, there's, you've got your spider active scans, and we've done fuzzing, but we can do forced browse site. And so that's the equivalent of what GoBuster does. And so it even comes with its own directory list, but in the settings, you can add your own. So like if we start this, it'll probably find a couple of, although there's not much going on in this web application because it's literally just vulnerabilities and /root and stuff, but that does the same thing as GoBuster. And I haven't even introduced you guys to Hydra, but when we were doing the fuzz, yeah, so it's finding some stuff already. I guess since I kind of haven't introduced individual tools, the coolness of this tool might be a little lost, but so like usually, and even in most standard like hack the box tutorials and walkthroughs, it'll even go like use burp suite and then convert the request and craft a long Hydra command and to do a login brute force for a web application. You can just do that in ZAP. Or if you've got, craft a GoBuster command in command line, and you got to remember this, or copy and paste the command from your notes, you can also just do that in ZAP. It saves, it makes things move a lot quicker. Oh, and also since we're authenticated, we can perform like another automatic scan, and it'll be able to see more than it did before. So it's on max, yeah. So it's able to look in at all these like DVWA that it wasn't able to see before because we weren't logged in, and we didn't have that authenticated session. Okay, so that kind of covers pretty much the bulk, or maybe not the bulk of OWASP ZAP, but it covers like what you'd be using like the majority of the time as like an intro pen tester. There's also a bunch of neat extensions and stuff that you can take looks at, but they kind of just add more functionalities. But I'm not going to be going too into detail to that. This is not a we will just be using ZAP in the future for like other web application testing and the other labs this month. So I want to make sure you guys got that set up. File. What did I do? CSRF token is incorrect. I've not had this happen before. Did I change the sessions? Maybe I broke the application. I'll just restart. But I'm just going to try to talk more about the other stuff that's available to test against with the damn vulnerable web application until we kind of like run out of time, I guess. So I'll cover cross-site scripting as well once this is done, because we also covered that in the PowerPoint slides. So it uses all web application, or pretty much all web application vulnerabilities is just from user input and like how it's not sanitized properly. In SQL itself, it's got we'll cover like proper coding practices for the SQL room. There's ways to actually put in user input that is not parsed as like a command, and there's also that one for there's tags for that in JavaScript. Probably cover that in our dedicated cross-site scripting room. I'm just trying to pad time until the IP address is revealed. I can give you an example of cross-site scripting. Okay, there we go. So here's an example of cross-site scripting, and we're not going to do blind SQL injection because it's the same thing as SQL injection, it's just you don't see the output. So we got like a little language prompt. So that's not any user input, right? There's no user input here. But there is. We see at the top, it parses our selected language just in the URL. So what if we put some random stuff in here? Let's put in Joe Mama. Joe Mama is a language? Yes, Joe Mama is indeed a language. So if Joe Mama is a language, surely, script alert Joe Mama is also a language. Let's see. Oh, what did I script? Damn, I'm supposed to get like an alert out of that. Let's try that again. Oh, I think my actual like Firefox extensions are blocking the alert that would pop up. But it would just give you an alert that pops up Joe Mama. Can I remove extension? No, because it's just included with the Parrot Security Firefox. Okay, cool. But they're both the same concepts of just the input isn't properly utilized. Yeah, the about pop-up is being blocked, but you would get an about pop-up and it would just pop up on your screen. And in that case, if it was stored, and then you can do like the same kind of thing, since it's so the difference between the domain means it's in the, well, the domain, like the address. And so then the stored, like if you're leaving a comment and it doesn't separate whatever your comment is from the HTML code, then it's just signed into that HTML code. Again, I should have thought a little ahead of time. I had the virtual machine set up for this, but of course at the very like 30 minutes when I was getting ready, the grub menu for whatever reason just was not working and the virtual machine got nuked, and I had to like download a fresh one, and so some of the configurations for it to be like a standard web browser I didn't properly make. But alert test 1. No, I'm pretty sure it's just because it's changing the I feel like it's supposed to be rendered, but yeah, I don't even have any other web browsers installed. Okay, but that's kind of like a basic introduction. So you can mess around with the other stuff here. There's more reading materials included with all of these. We've done file upload, and we'll have one on file inclusion next week. And then the following week after that, we'll have one off of specifically SQL map and SQL injection. And then I still have not decided about the last month. We'll either have a challenge one or something about either a challenge to like test kind of what you've learned as learn about your web application skills, or we'll cover another topic, but undecided. That kind of concludes today though. Next Monday we'll have another just like hacker hangouts, and also I kind of just wanted to get user input. So we've gotten the go-ahead to open up to like have in-person physical meetings. Do you guys want, like, if we had in-person meetings, would you guys like actually come or like attend? Yeah. Well, I mean, I try to do both, but I also wouldn't want to go to the certain, like, because there's a lot of extra legwork that needs to go in to have a in-person meeting at the moment. I know some of the other clubs are kind of just like, nah, we've been doing it online, we just gonna keep doing it online. So that's kind of how I'm feeling. But if there's a desire, if there's a want from club members to have a more physical presence, then I'll put in that effort. So, request for input. What do y'all think? I think I'm thinking for next month, if because currently there's really no reason to have anything in person. I know next semester, now that we're official and we'll be getting a little budget, we'll have real hardware to like use and test against, and for that, there's a benefit for having it in person. Yeah, because there's like yeah, it'd be so short lived anyways. All right, we'll just stay online then. Um, any questions? Any requests? That kind of thing. I'm trying to.